coming for this late shift today. I hope that Matt and I will be able to embrace you in some new information and maybe help you to decide whether you feel palm oil is a friend or a foe. So I'm going to start with a little bit of a background really to palm oil, and then Matt's going to really get into the nitty-gritty and give you a feel of the kind of science that we're doing here at the University of Kent. So you can't really understand palm oil without thinking about some key truths. Some things that we all talk about day in, day out, but we don't think about their relevance to agriculture. Number one is that the earth is warming, and that is due to human activities. Secondly, we just heard forests are burning, and this is happening all over the world, not just in the Brazilian Amazon, Indonesia, Africa, and so on and so forth. And wildlife is being lost at rates never experienced before. Now you, me, and most of society are pretty upset about this. We had an amazing talk about this last night. I think that really sets the precedence for understanding the science that we're doing here at DICE. But the crux of the problem is that the world has a lot of people, 7.5 billion at the moment, and this may be up to double by the end of the century, or probably at least 12 million by the end of the century. So the key question is, how on earth are we going to feed all of these people and provide for them in general? The computer's frozen because there's so many people. It really has.
We've got another 30 slides of people.
So how are we going to feed them? We need land, right? And if yields of agriculture remain at their current levels, we'll need an area the size of Canada, which by the way is the second largest country on the planet, of conversion to agriculture to feed us all. That sounds like a problem to me, because this is normally done at the expense of natural habitats. So, for this reason, agricultural scientists and scientists like us that work on conservation are quite interested in crops that have high yields per unit area of land. We think that these maybe could be beneficial. In comes palm oil. But I left a question mark there because that's the question we're asking this evening. But to understand the palm oil problem, we need to go back a few years. So palm oil comes from the fruits of the oil palm tree, which is native to West Africa. Since 1995, palm oil production has quadrupled to 10% of global cropland, making it one of the most important crop plants on this planet. And you can see this expansion is across the tropics, but more recently is concentrated in Malaysia and Indonesia, which produce about 85% of all palm oil. So why has this happened? Well, in the early 90s, scientists warned about the link between trans fats and heart disease, and indeed saturated fats. Now, luckily for palm oil, saturated fat is in low quantities in palm oil, and it's free from trans fats. So almost overnight, the industry that made butter, ice cream, various things, shifted away from butter and other oils, all onto palm oil. And quickly, Malaysia and Indonesia were the fastest countries to pick up on that, and they started growing rapidly. Now today, palm oil is in 50% of products. You washed your hair with it this morning, you ate it at lunchtime, and you're really happy because in the summer, it keeps your ice cream from melting. This is pretty unavoidable really at the moment. We also have to think about the economic contribution of palm oil. Not just what we can consume, not just the problems. And indeed, in many tropical countries, it's been used as a way to alleviate poverty in local communities. For example, Indonesia and Malaysia is one of the most important contributors to their gross domestic product. It's a key driver of economic growth. What about the land? That's what we're really interested in as conservationists. Well, there's good news for our palm oil there as well. Palm oil yields about 9 times, at least 9 times, more oil per unit area of land than other edible vegetable oils. Things that could be in your ice cream, could be keeping your cookies soft, or indeed could be keeping your lipstick smooth. So that means that the palm oil problem is complex. This is mainly around the fact that palm oil is grown in the tropics, and as a result, with devastating environmental consequences. Why is that? Because tropical areas harbour the most ecologically complex terrestrial systems, and when you cut down an area of rainforest, you lose more than you do in other habitats. To illustrate this, in Southeast Asia, you can see forest loss over the last 20 years. And about 40% of this is due, at least 40% of this is due to palm oil. As you might expect, with this, we have a wildlife crisis in Southeast Asia, and indeed other parts of the world. You've heard about the last Sumatran rhino in Malaysia. You may have heard of human-wildlife conflict in palm oil plantations, elephants being poisoned. And you've almost definitely heard of this 100,000 orangutans killed over 16 years. And much of that is due to forest loss. And this work comes from wonderful work by Maria Voigt, who's sitting in the middle over there. And more recently, some work by Dave Seaman up at the back. It's shown that indeed, orangutans are being lost in these areas, but they can also hold on in palm oil plantations. And Matt will go into that in a bit more detail, albeit at lower densities than they would be in really forested areas. So palm oil has become the forbidden fruit. And as a result, producers are starting to market products that are palm oil free. They're starting to try and remove palm oil from their products. And they've used the orangutan as their pin-up for those. Last year, the supermarket Iceland pledged to ban palm oil altogether in their own products. And in doing so, they had a massive marketing campaign around Christmas. They had this video of an orangutan in a child's house in the UK and couldn't go back to its native forest because it had all gone. Now, the advert was barred from TV for being made by a political organisation, but it was viewed over 12 million times on social media. And Iceland made a big thing of this, saying that they're going to ban palm oil because they don't believe that palm oil can be sustainable. But myself and Matt and other colleagues, we asked the question, well, is a ban really the answer? And as a result, we were invited to write a piece on this, which had over 100,000 reads. And what we were saying is that maybe boycotting palm oil was not the answer. Maybe sustainable products are the way forward. And we'll talk about why in a minute as well. But it really focuses around the fact that palm oil is such a high-yielding vegetable oil. Also, bans are very hard to implement. Iceland themselves couldn't do what they said they were going to do. Instead, they just took their name off those products. Doesn't sound like a ban to me. So basically, what we have here is a problem that's not easily solved because palm oil has become the pin-up for NGOs about the environmental crisis in tropical forests, and that's a good thing to raise in the public arena. However, there's a dangerous message if we're suggesting banning palm oil because actually it's more productive per unit area of land, and if you shift onto a different oil or a different product, you might actually require more land. So given that palm oil demand remains, human population still increasing, Demand is predicted to double by 2050. What is being done to reduce the negative impacts of palm oil? Well, certification is one way. So you may have heard of bodies such as Fair Trade or the Rainforest Alliance. Have you heard of the RSPO? Put your hand up. I would say vastly less than a third of you. And we work in this stuff. But actually 19% of palm oil is certified by the RSPO. And what the RSPO does is they work with improving practices around palm oil for people, prosperity, so keeping it economically viable, and our bit, the planet, the environment. Now the RSPO set out principles and criteria. I'm just going to focus on two today, because that's really what we do here. The environment and people. And basically, to get certified, palm oil grower or producer or consumer or sales body has to go through these processes. But interestingly, certified palm oil is not often labelled as such. And that's because some companies that sell palm oil or products with palm oil in don't want to label it as palm oil at all. So they call it vegetable oil. And they've been getting away with that for years. So even though they go through this huge process to certify here at the plantation, at the mill, during transport, in the supermarket, all the way to you as the consumer, it's still not labelling as certified palm oil. So this is the area that we work. We are interested in what's happening in palm oil plantations themselves. So we need to improve the landscape for wildlife. I'm going to hand over to Matt to tell you what does the science say about the landscapes for wildlife in palm oil plantations.
Hi. Okay, so I'm just going to flick back to this one here. Okay, so as Jake said, when you're buying a sustainably certified oil palm or palm oil product in a supermarket, it needs to be certified at all these stages in the production cycle, in the supply chain, right? From plantation, where it's grown, through to the mill, where it's processed, through to export and import, through all the manufacturing processes in the retailers and the supermarkets that you buy your product today. But what we're interested in is what happens with wildlife, what happens to biodiversity, whether these sustainable practices equal best good practices for wildlife. And the vast majority of that is actually the way that oil palm is grown. So that's what I'm going to focus on today. Now, like many tropical ecologists or tropical conservation people, I spent the early years of my life avoiding this issue by sitting in very nice, lush tropical forests, being eaten by leeches, but seeing lovely wildlife. And when I did my PhD 15 years ago, not that long, I was forced really to see much more of the land outside of the protected areas, the protected rainforest where I was working. And the really interesting thing for me and a lot of people of my generation then was that actually very, very little was being talked about the oil palm problem. Only when you were actually seeing it with your own eyes were you really, I guess, your eyes open to the extent of the conversion. And it wasn't really out in the public domain. It is very much in the public domain now, but very less so then. So a group of us, 5 of us actually, set about to see what the impact this was having on the environment, and particularly on biodiversity. We all studied different wildlife groups. And so we were looking at studies that compared oil palm plantations with rainforest, and we found very few of these studies. So here I'm showing the available studies that were around then, 15 years ago, ranging from lizards, birds, bats, primates through to invertebrates such as beetles, ants, mosquitoes and moths. And on the y-axis here, we're showing the number of species remaining in the oil palm once it's been converted from forests. So we've rescaled the axis here to show that what the 100% of the forest species would look like in the oil palm. So if the bar is above this line, you've exceeded the number of species that we would expect from rainforest. So these are simply studies that have compared the number of species in a forest transsector survey with an equivalent survey in an oil palm plantation. And what we see is that for the vast majority of wildlife groups assessed, there's vastly lower or reduced species numbers in oil palm plantations compared to forests. And this is not that surprising because this is what happens in agriculture, but it's somewhat surprising the extent of the problem in oil palm compared to other agricultural products. One exception is a study of bees, which was actually restricted to the understory, to the lower parts of the forest. And what we know about bees in tropical systems is that the vast majority of species and activities up in the canopy, where the nests and hives are up in the canopy there. So overall, around 85% of the species that we would expect to see in a tropical rainforest are lost when you convert it to oil palm. And there have been more studies since, but this overall number is around the same. So what this tells us is that if we're trying to improve biodiversity conservation, wildlife conservation in these agricultural areas, in these oil palm areas, the best gains are going to be made from improving the amount of forest in the landscape and the quality of the little smidgens of forest that are scattered in the farmland landscape of oil palm. And this is where ecological theory and ecological applications come in, because decades of ecological research tell us, if I can actually press the right button, that we expect more species when we have larger habitat patches, right? So when we have more rainforest, if our little patch of forest is bigger, we expect to find more species in it, and we expect to find more individuals of those species, so we expect the populations to be higher, right? So we expect when patches are larger, we get more species, and when patches are more connected or when they're less isolated, we expect to get more species as well. And this pattern is seen across the world in lots of different systems. And so how do we put this into practice? So when you buy your certified product, your RSPO certified product, plantation company that is producing those fruits needs to undertake previously it was a high conservation value assessment, it's now a high carbon stock assessment. And so the high carbon stock approach is a toolkit, it's a methodology that addresses commitments of zero deforestation or zero net deforestation. And what this involves is identifying areas of natural forest in the estate, in the oil palm estate, and distinguishing that from areas of degraded land. So the natural forest areas can in theory be protected if they've got some value to conservation and all these other things that we were interested in. And if it's of low value, then it's converted. To do this, the land is mapped, and then these patches of natural vegetation that remain are prioritised using ecological criteria. And typically, the network of patches that remain in a system, if there are any, are around 1 to 3 kilometres. They can be smaller and they can be a bit larger, but they're typically within 1 to 3 kilometres. So I've been working in Borneo for 18, 20 years now. And one of my PhD students, and now postdoc Nick Deere here today, he validated this toolkit for mammals. So we were interested to see if this toolkit actually worked for biodiversity. But first we just want to go through actually what this process involves. So firstly, we get satellite imagery for the plantation area, and we classify that vegetation into different habitats based on the reflectance on that imagery, right? And we can distinguish what areas that are high carbon stock or high biomass. These are very complicated systems akin to a lush tropical forest, from several different categories, going down to quite scrubby vegetation and open land. And the idea here is that rather than just delineating what is and what isn't forest, we've got a whole gradient of different qualities of forest in the system. And anything below this threshold here, so anything below this young regenerating forest type, can in principle be cleared for development. Okay? But this is what it looks like in practice. This is an area of Gabon. And this area is classified, compartmentalised into these patches and classed into these 6 different classifications. So we get a zonation map of different forest types in the system, or different land use types, and over a substantially complicated prioritisation pathway, we end up with a map, a zonation map, which is saying what can stay and what can go to all palm. Okay, and typically it's a network of high biomass or high tree biomass forest patches, and it's connected by a network of little slivers of vegetation here. Okay, so when you're buying your sustainable palm oil product, the plantation where it was grown would have to go through this process. It would have a management plan in place for all these areas of forest here. So for this to work for wildlife, we want to know whether the species that are of most concern to us as conservationists are represented firstly in the land that is actually marked out as high carbon stock or high biomass. Secondly, whether those species are present and active in patches that are prioritised for protection. And thirdly, whether those linkages that join the patches are also supporting those species as well. So those are our 3 red lines, to quote a defunct member of our political establishment. Those are our 3 red lines for our high carbon stock. So we worked in Malaysian Borneo, in the state of Sabah, and we set up a camera trapping campaign over the stability of altered forest ecosystems project in Sabah. And this is the world's biggest landscape experiment, where a whole network of scientists from around the world, from Malaysia, UK, and many other countries, are working together to characterise the forest functions and how the forest system is being affected by land use change. This whole area of forest here is being converted over to all palm plantation, and we're tracking the changes that happen to the forest through that process, so that we can advise forestry companies, governments, and all palm companies how to mitigate those changes, and how to improve the system. So Nick and Lonnie Baking, another student over in Malaysia, they set up a network of camera traps over the landscape over a number of years. And for those of you that are less familiar with these are automated cameras. They're the animal path. You leave them in anywhere you like, really, and anything that walks in front of it sets off the camera. And they're really good for detecting elusive and particularly nocturnal and particularly rare species. So in principle, you can set one of these up and go back and get back to your day job and collect the camera 2 or 3 months later, unless somebody steals it, or an elephant destroys it, or the ants destroy the camera, or many of the other problems that we encounter along the way. And so over a number of years, Nick and the team used 115 of these cameras over the landscape. This was over a combined total of 14,000 camera days, generating almost 500,000 photographs. And this poor team identified mammals in 83% of those photos. So they spent a lot of time looking at computers, counting animals in 400,000 photographs. I will, just to clarify, most of those photos had nothing in them, right? But there are mammals in some of them. And it's actually really quite surprising what you can find in these photographs, right? We're getting Asian elephants, we're getting clouded leopards, we're getting common stuff like muntjacs, but they're just amazing. We're getting orangutans fighting, we're getting yellow-throated martins dancing and playing with each other. We're getting pangolins. I haven't seen a pangolin since 2005, and they're there on the cameras in high carbon stock forest over in Sabah. So we're getting a whole array of species in these heavily logged over forests and these high carbon stock patches. The second good news is that when we use some pretty horrible statistics that only Nick appears to understand, is when we classify when we look at the numbers of species that we are seeing in the system, classified into these different HCS habitat classes, we see that, as we would hope, most of the species are represented in the highest priority classes. So the areas that are being demarked out as high carbon stock and as high priority for conservation are indeed representing the mammals that we tend to care about. These tend to be things like clouded leopards, binturong, which not many people have heard about, but they smell like popcorn. They tend to be orangutans, that of course everyone's heard of. And they tend to be the coolest animal in the world, which is the tufted ground squirrel. There is some disagreement in the area in these two classes that are actually on the edge of what stays and what goes in terms of land conversion to oil palm. But these inventories tend to be inflated by species that tend to be common anywhere in Borneo. They could be rats, they could be porcupines, they could be the things that eat rats and porcupines. They tend to be of less conservation concern than these cute and cuddly things up here. The third bit of good news is that the larger and more connected these patches of forest are, the more mammals we are detecting in terms of species, but also in terms of the population size. So the bigger the patch, the higher the population, right? And when we partition these analyses by the priority status, whether the patch is low priority, medium priority, or high priority according to the HCS scheme, we see that for all the specialist species and for all the threatened species, i.e. the ones we care about as conservationists, they also tend to be more represented in the higher priority patches. So this is actually quite good news. They're not found exclusively everywhere, and of course some of this rainforest is being converted to oil palm, but at least it seems that the tool that is there designed to design the landscape for conservation and retain a network of some patches is actually representing many possibly happy animals, which is this bit here. The main caveat is that even though area is this great predictor, and even though isolation is this great predictor, the fragments would still need to be about 30 kilometres squared in size to actually sustain big enough populations of mammals, viable population of mammals. And to put this into context, 30 square kilometres is the size of a typical small plantation in Malaysia. We've been in plantations that are much larger than this. So if some of the land needs to go to oil palm, we're in a bit of a sticky predicament. So this really points to the fact that we rather than treating these little patches of forest independently, we need to be considering them as this big mosaic, not just within the plantation itself, but in whole networks of plantations, right? And this is actually what the HCS toolkit's all about. It's all about joining up patches as well as defining what they are in the first place. So the second way that we try to influence practice is to look at the connections between these patches. So this is a typical land use plan for an area of land going to oil palm. These are the patches that we've just demonstrated have quite decent numbers of species, quite fairly decent population numbers. And we're trying to strive to connect them so that all of this can be treated as one big system. And typically, these connections in tropical landscapes are around riparian areas. They're around the areas of vegetation left set aside against the rivers. And there's actually very little known about what value these have for wildlife. There's some recent work, or our work has actually been covered in Mongol Bay articles, but we're starting to put this out into the public domain now. So Sarah Luke, who used to work with us here, she joined us a few years ago, and she set about reviewing what information was available for all of the values that we could place on these riparian zones. Right? And so there are many reasons why you might want to protect a riparian zone and protect a forest next to the riparian zone. The primary reason is because productively that area is actually low yield for a lot of agricultural crops. Right? You've got lots of flooding, you've got poor water, you've got high water retention in soil. It's usually not good for growing crops. So these areas tend to be left unplanted. But also riparian buffers or protected reserves, they maintain hydrological processes in the rivers, they minimise flooding, they reduce the erosion and runoff from the farmland into the river system, they maintain habitat for freshwater species, they maintain clean water supplies for people, they're good for carbon cycling and carbon storage in the biomass in the forest there as well. And in principle, they're good habitat for wildlife and good connections for biodiversity. But that's what we don't yet really know. So what Sarah found in her review is that legal protection is actually afforded in most tropical countries, as it is in temperate countries such as the UK. So countries have rules and legislation that dictates that an area of land must be set aside for conservation purposes or protection purposes either side of the river. The problem is that these guidelines or legislation is highly variable between countries and even within a country, and often the terminology is quite vague. So actually, it's poorly implemented. And a great example of this is actually where we work in Borneo, which is split between 3 countries. Each of those 3 countries have different rules, and even Malaysia has different rules depending on what state you are in Malaysia. So in Sabah, if a river is less than 20 metres wide, 20 to 30 metres either side of the river must be set aside as forest and can't be planted with any agricultural products, whether it's all palm or not. If the river's wider, 20 metres, then a 100-metre buffer must be retained. But if you were to step over the border into Indonesia, it's different rules. So if plantations are operating either side of jurisdictional boundaries, they have to apply different rules in different contexts. And nowhere is this really joined up. Okay? The other big sticking point here is that there's actually very little evidence, scientific evidence, informing the effectiveness of these riparian buffers for protecting wildlife and actually many of the other functions that we need for healthy ecosystems. So of the 265 tropical case studies that Sarah found, only 8 of them in 50 years gave any actual recommendations on how big the riparian reserve should be to improve the environment of the river or the wildlife around there. And to put this into context, this is the range of width recommendations for temperate countries, and this is the range of width recommendations for tropical countries. So most of the policies, most of the prescriptions for tropical countries are actually borrowed from legislation from other countries around the world, and no one has actually determined their effectiveness and put this in the public domain. So we set about establishing a research project on this back in Sabah in collaboration with 2 departments in the Malaysian government and colleagues in the University of Oxford and University of Malaysia, Sabah. And we worked in 28 rivers across the SAFE project landscape. And some of these rivers were within continuous logged forests, so they were completely surrounded by forests, very heavily logged, but still forested nonetheless. Some of those rivers were in all palm, completely devoid of any plantation, any vegetation apart from the palms. But the majority of them had one of these riparian reserves, and they differed in the width of the reserve. And again, we were actually quite surprised with what we find. We find sun bears in there. I've never seen a tarsier in Borneo, but there's one 7 kilometres from forest somewhere in the SAFE project. We see orangutans, we see the cloud leopards. They're using the riparian network way out in the oil palm. So they're hanging on. There may not be a very high population densities, but they are using these riparian zones. And so when we compare the numbers of species in several indicator groups, so here are small mammal studies that we've done this research over. So small mammals, birds, dung beetles. These are the beetles that begin the decomposition process of all the poop in the system. And we look at dragonflies and damson flies, which are really great indicators of aquatic health and healthy fresh water. When we look at the biodiversity values, so the number of species that are there found in the riparian reserves, they're always more than what would have been there in the absence of that reserve. So they're actually useful to have them. It's not perfect, it's not all rainforest, but it's better to have one of these riparian buffers than have no riparian buffer at all. And one of the great examples, or the best examples for this is Simon Michels' study. So Simon is somewhere in the audience over there. And he spent a long time looking at birds over at SAFE and these 28 rivers. 6,000 bird encounters and 840 independent point counts later. We can have sufficient data for birds to be able to tell you what that optimum buffer width should be. So how big the riparian buffer should be to represent all of the species that we would expect from if it was a continuous tract of forest around the river. So here we have on the x-axis the riparian width here, and the number of species, or the percentage of species remaining here, and the optimum width area is here. And that tells us that buffers should be at least 40 metres either side of the river to be comparable to forest for wildlife. But if we're more interested in the species of conservation concern, so these are the threatened species, those that are endemic or only found in Borneo, for example, then it would need to be 100 metres set aside either side of the river. The really useful thing for policy here is that 40 metres is actually not that much more than the dictated amount in Malaysia, And so the Malaysian government is genuinely interested now in overhauling their policies and in increasing that width requirements. So this is one plantation system in a small bit of Malaysia, in a small bit of Borneo, in one country, across the whole production region of oil palm. So how do we scale this up, right? How do we really evaluate whether the certification systems, whether these sustainability standards actually work? And to do this, it's incredibly complicated. And it's complicated because we need spatial data that we don't always have. We don't have it from Malaysia, for example. We need information on where plantations are, where certified plantations are. We need reliable data sets on wildlife or on proxies for wildlife, such as forest cover. And we need other information from companies or the RSPO process. We're beginning to get that information from some countries like Indonesia, which, as you will remember from Jake, is the biggest oil palm producer in the world. And some of the lessons that we're getting in recent years is that actually, so they are in Sumatra and Indonesian Borneo, so this is all this area here, Kalimantan. RSPO certified plantations had 33% reduction in deforestation compared to their counterpart plantations that weren't certified, right? So they weren't obviously removing all deforestation because it's being producing, but they were retaining more forest than if it wasn't certified. So there is some benefit to having RSPO certification. It does seem to be working to a certain degree. It's not perfect, but to a certain degree over this part of Indonesia. However, more recent work this year from Sarah Struebig and colleagues at the University of York has shown that actually when she looked at the plantations that were certified in Kalimantan, in the Indonesian part of Borneo, only around a fifth of those actually didn't have any forest in those set-aside areas at all. It was just scrappy land. Now, all of this was done before this high carbon stock approach was used in the certification process. So I'm highlighting this because it demonstrates that there's often a time lag before an intervention is put in and when those benefits can be realistically expected in the system, okay? Whether that be for wildlife or for anything else. To do this properly, what we need are big spatial analyses. These are what we call counterfactual analyses. These are spatial matches of what would have happened in the absence of oil palm. So again, we need maps of palm and non-palm. We need maps of certified palm and non-certified palm. And we need to be able to track those over long periods of time. So this is a typical counterfactual assessment. This is what would have happened in a control site if there wasn't any oil palm plantation. The forest may have stayed or it may have been slightly logged or something. This is what happened in our treated site. What makes it more complicated when we want to see what happened with RSPO is that we have to do this counterfactual assessment for three different comparisons. Right? We're looking at whether it's palm, whether it's palm that's certified, and whether it wasn't palm in the first place. Okay? And this is a real big computational problem, and it's, tricky. I went through lots of different memes, and we tried so I kind of wish I'd gone for the other one. Okay, so lastly, I just wanted to emphasise some of the extraordinary work that's coming from these big, scary counterfactual analyses. And that's from work from Trudy Santika, who's part of DICE, but she can't join us here today. She's based in Helsinki. And what her work is demonstrating is that the impacts on people living and working in plantations is inextricably linked to the environment in those and the forest cover in those plantations as well. And what Trudy did through these counterfactual assessments is she took 18 indicators of poverty from Indonesia's national census data set over 20 years in Kalimantan. And what she found is that over the majority of these poverty indicators, that for the majority of those indicators, they were made worse. So poverty poverty increased in areas where oil palm went in, and particularly in areas where oil palm was established, where there was forest nearby, right, or where there was recent deforestation. However, poverty was alleviated, or poverty levels improved, quite substantially so, in areas where oil palm companies were established. It's always Richard. Not very well. So poverty levels improved where oil palm was established in areas, in villages that had already got agricultural livelihood systems set up. So the moral of the story so far in these kinds of analyses is that in areas where you've had recent deforestation, you don't get the improvements to society or to rural communities that you would hope for from oil palm. But in areas where there's already a long history of agricultural production, very, very far away from forest, then you do actually reap the benefits in terms of poverty alleviation. So I highlight this because it actually means the improvements that we can put through in certification, sustainable oil palm production for deforestation are also linked with what happens with people and vice versa. Okay, so lastly, one thing I just wanted to emphasise is that oil palm is just one crop of many production systems in tropical countries and around the world. It's oil palm, it could be soy, it could be coconut, it could be wheat, it could be maize, it could be rice, it could be coffee, it could be cocoa. Now, oil palm has attracted a lot of attention, but we could all of these principles in these certification systems and sustainable livelihoods can be applied as equally to any of these ones today. So, on that note, rather than thinking of palm oil as your friend or foe, I would like to put back to you, is sustainable palm oil your friend or your foe?